know 0 to 0 is just 30, right? Because it started off at 30 cubic feet in the pipe. So now if I check 0 to 8, so I'm going to do menu for 2. Oh, wait, I forgot to put 30 in. 30 plus 0 to 8 of F1 of X minus F2 of X dx. And then 30 plus 2. I stored my little 0 as W. Whatever you stored it as, that's what you're going to want to put in. And then F1 of X. Yeah. Unfortunately.
I would probably skip it by now. Yeah, I put skip. I'd be like, nope.
Alright, so the minimum happens at that time that we found. The minimum is 27.965 because at 8, 48.544 cubic feet in the pipe. So
Is getting the filming wrong the same amount of points as not doing? Like if they
saw they don't count off for anything
if
wrong.
They saw that you did all this work and you did it wrong, will they give you anything or no?
I mean, they only give you points for stuff that's right. So like on this one, the points would have been for, it's 3 points, and the points are for 1 point for finding where it's equal to 0, so finding that 0. 1 point for figuring out that the minimum is 27.965. Oh, I guess it asked for the time. Oh, it did ask for the time. Sorry, at what time? The amount of water in the pipe is the minimum at time t equals 3.272. And I guess the justification is just showing where you considered all of these. So, yeah. It would have been hard to get really any of the points on that one. Yeah. Like I said, it's really like once you know how to do it, it's not that, I mean, it's tedious, but it's not like terrible. It's just realizing that's what you need to do is kind of hard on that one. Alright, part D is worth 2 points, and I don't think part D is that hard. It says the pipe can hold 50 cubic feet of water before overflowing. For T greater than 8, water continues to flow into and out of the pipe at the given rate until the pipe begins to overflow. Write, but do not solve, you don't have to solve it, just write an equation involving one or more integrals that gives the time W when the pipe will begin to overflow. So the pipe's going to overflow anytime the total amount of water in the pipe is more than 50, or is equal to 50 or more, right? So we already wrote an equation for the amount of water in the pipe, or we already wrote an expression. This tells you how much water is in the pipe, right? It's the starting amount plus the total change in the amount of water in the pipe. So all I have to do is just set this equal to 50. Right? Whenever the total amount of water in the pipe equals 50, the pipe will overflow. Yeah. Right.
So what if you did how would you do?
You would get 6 points if you did A, B, and C.
No, but if you try to do
if you didn't do C, how would you do?
Yeah. Like you have
to
do C to get
No, if I hadn't done C, I could still figure out the total amount of water in the pipe. I mean, this is something that if you don't know it, that you do need to know. It's not, I mean, it shows up in a lot of places. If you have a rate of change and you want to know the total change, you're going to integrate. So we know the rate of change of water in the pipe because we know the rate it's coming in and the rate it's going out. So the rate of change of water in the pipe is the difference between those. So we just integrate that to get the change in the amount of water. And it started with 30. So this is pretty common, like this idea of the starting amount plus the total change. We'll see that on a few other problems. I think that you'll be more comfortable with that after we do a few more of these. So you would just write it, you would just write this expression on part D. If you skipped part C, you would still need that on part D. Yeah. So it was 1 point for writing the integral part of this, and then 1 point for putting it in an equation equal to 50. So really, I mean, if you just wrote that, you would get a point. Adding the equals 50 gives you the other point.
So we could have gotten 6 points.
No, you had it right on that.
If I had right on that one.
What's your adjusted?
I don't know. It's not really an equation if it doesn't have something on the other side.
Wait, so
Probably not.
all of them but C, that's 6 points?
Yeah.
Bad, bad.
Yeah. Like there's always gonna be, I mean not always, but on a lot of them there's gonna be one of the parts that like is just gonna make, I mean it's, they're trying to separate out the fives from the fours and the threes, so they're trying to make part of it a little bit harder. But like on, let's say that you didn't get, like, let's say you tried part C and you wrote the wrong expression, and but you thought you were right. So down here you came and you wrote that same wrong expression in your equation, but you wrote the equation. But let's say you forgot the 30, or you forgot to subtract them, or you added them instead of subtracting them, or something like that. You would still get the point for the equation. Yeah, I mean, like, you can make up, like, I mean, it needs to be something that's an honest attempt. Like, I mean, I wouldn't just write, like, x squared plus 2x minus 7 equals 50 or something. But if they can tell that you made an attempt and you just got the integral wrong, but you wrote the correct, but the equation needed to equal 50, you would still get the point. So, yeah. You're better off writing something, I mean, especially if you have the time, than leaving it blank. Like, I would make some attempts if you have the time. Like, if you feel like you can. Yeah, you have about 15 minutes of problem for the free response. So, like, A, B, and C would not take you 15 minutes. I mean, those problems are, those parts were not that hard. Part C would take up most of your time, I think, because it's so calculator heavy. You have to do a lot of stuff in the calculator on that part. Alright, let's see. Alright, so let's look at real quick. We won't do all of this, but look at 2013 number 1. This is 2013 number 1. This is a very similar problem, except instead of gravel, instead in and out of a pipe, it's gravel in and out of plant, but it's the same thing. So we'll just do part B on this one. I just wanted to show you, like, we'll do the other parts on Saturday, but this is very similar to that problem that we just did. It says on a certain workday, the rate, so this is a rate problem, in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by this equation, where T is in hours, and they're even still using the same 8 hours, 0 to 8. So this is another rate problem. You've got the rate, this is kind of like the water flowing into the pipe, this is the gravel flowing into the plant, right? You have this coming in. Right? Yeah, they try to be all real worldy, and it's so bad. Alright, so at the start of the workday, they start with 500 tons of unprocessed gravel. So just like on the last problem, the pipe starts off with 30 cubic feet of water in it. This plant starts off with 500 tons of gravel in it. During the operation, the plant processes gravel. This one's a little bit easier because the rate that the gravel goes out is a constant. It's just a constant 100 tons per hour. So they do, over the course of the 8 hours, they process 800 tons because they're doing 100 tons every single hour. It doesn't change. So it's a little bit easier in that respect, so that the rate that it's coming out is not another equation. It's just a constant. Alright, so if you look at we'll do part, actually we can do part A, it's really easy, we'll do it real quick too. So part A says find G prime of 5, and then using correct units, interpret your answer in the context of the problem. So you can do a derivative of a function at a point in your calculator.
Wait, did you just find the derivative?
Yeah, I mean you could find the derivative of this, but it's going to be kind of a pain because you're going to have to use the chain rule on this part. So it's better to use the calculator. They designed the problem with a fairly tricky equation to force you to use the calculator, because part of what you're supposed to be able to do is do calculus in the calculator. So they want you to do it in the calculator on this one. So it's really easy. There's a template for it. It is on the second row, the next to the last one, where you see the D over D box, right? So that's derivative. Or if you press menu calculus, it's number 1 instead of number 2. It's a derivative instead of an integral. Right? Doesn't matter which one you use. So if I use the template, the problem with using the template is you have to remember things. Okay, I'll show you what it is. Alright, so we're gonna do the derivative of 90 plus 45 cosine, oh, and I used x instead of t, it doesn't really matter, x squared over 18. Hold on, I gotta remember where we have to put this little symbol though. Hold on just a second, I'm just trying to remember, okay, I think that's right.
So what would happen if we just found this derivative very important? Like,
It won't, the calculator won't find the derivative for you. It'll only plug into the derivative for you. Yeah.
How do you get the x equals 5 with it?
Hold on, I'm about to show you just a second. I just want to make sure that I put it in the right place. Okay. All right. So put it all for you. What I would recommend doing instead of this, I'll show you how to do it this way. But instead of using the template, I would do the menu calculus number 1, because then you don't have to remember that little part where you put in x equals whatever. It will do it for you. So you tell it the variable is x. The value that we want it to calculate at is 5. We're doing the first derivative.
And what is that to get that one?
Menu, calculus, and number 1.
Oh.
And so it automatically does that part for you. And so then all you have to do is type in the equation. Now, if you want to use the template, you can. You just have to remember how to tell it to plug in. And so the way that you do that, when I type this in, right, I use the template for derivative, but then you have to tell it to plug in x equals 5. And so you have to use, this is why I wouldn't recommend this, because it's kind of tricky, you got to remember where it is. If you look right below control, there's the equal button, and right above the equal button you can see in blue there's that little vertical line. That's what you need. So you bring that up, and then you type in x equals 5 after that. But if you use the 4, 1, or whatever, you don't have to do that. But that little line, that's in math, you read that such that. So we're saying find the derivative of this function such that x equals 5. Alright, so we're saying we want you to find the derivative when x is 5. But you have to put the little line.
What did you put the variable and what did you put the value?
The variable can be whatever you want. I mean, in this problem it's t. I just made it x. It doesn't matter. It just needs to know what variable you're going to be using, and the value is 5 because we're trying to find the derivative of 5. So we get negative 24.588, which is going to be in tons per hour squared, because
Do you use more than your decimal places?
yes, you can do more than 3, you just have to use at least 3. Negative 24.588, which would be tons per hour squared. Right? Because g of t was in tons per hour, so it was the rate of change, and we just found the derivative of that. So the rate of change of the rate of change. It's like acceleration. We found tons per hour, or tons per hour squared.
What if you got the units wrong? Did you get points?
You would, this part was worth 2 points, you would get one of them. You had to have the units to get the other point. Yeah, so you have to explain it. So this means that the rate is decreasing, right? Rate that the plant, or that the gravel is arriving at the plant is decreasing at t equals 5 or whatever, right? Because we got a negative value for that. So whatever rate gravel is arriving at the plant, that rate is decreasing. So it's going down 24.588 tons per hour every hour. So for this one I would do menu 4-1. Menu, calculus, and then number 1. Numerical derivative at a point. Alright, and then part B, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. This is just like what we had to do on part A of the other one we did. They want to know the total. and we have the rate. Right, we have the rate